Okay. So I will discuss about static, where that static memory is there. So and later I will jump to this class concept, everything. Okay. So right, programmers memory, how that memory is OS memory is divided. Um, right, generally how memory is divided. So we have actually four types of memories. Okay. Hello.
Yeah.
Yeah.
Yeah. Okay. This is called the code segment. Okay. This is called the data segment. Okay. And this is called the heap memory. And one more is called stack. Okay. Generally, we have these types of memories for any OS, means in the OS point of view. Any program runs means it have these types of memory. Okay. In main memory. Okay. Mhm. Mhm. Function just mm, mhm. Okay. Mm. So module, right, module is a static, right? Generally, module will be existed in the static environment. So here I declared int a, b, c, d, and c, d are part of function. Okay. So now how that memory will be allocated to this one? Generally, just I will explain. Generally, in the code segment, your code will be stored, and in the data segment, all the static means all the uninitialized variables will be stored in the this means all the initialization and non-initialization. So it will store both variables in the data segment. Okay, this heap memory generally will use for the dynamic allocation. I will explain later dynamic allocation. And the stack is like for automatic. I will explain what is this also. This is for automatic variables. Stack is for automatic variables. Heap is for dynamic. Okay. This data segment is used for the static. Okay. And this in the code segment, generally your code will be stored. Okay. So now we will see how this will be stored. Okay. Leave it this code segment. We don't need this one. Now we'll see the data segment. Okay. So so inside the module, tell me these are all these are static or not?
Static.
Mhm. What about the variables declared inside the function? Okay. So whenever module is there, if that program is compiled means at the elaboration time only memory is fixed for all the things. So whenever elaboration happen, immediately all these variables loaded here. So A will be loaded in this segment, B will be loaded here, and C will be loaded here, and D will be loaded here. Okay. But this CD are only their scope is within the display function only. Okay. And AB are part of module, right?
Mm.
Hello.
Hmm.
You understood, right?
Yeah.
What I'm trying to tell here. So, uh, um, so so data segment actually everything every static variable will be allocated here only. But whenever AB are like a just they are AB allocated here and D also allocated here. But we cannot access everything from the module. Okay, that I will tell you how why it is not unable to do it. So here C and D are also static. So means just I will remove this one. Eraser. Eraser is not coming.
You have to select.
Later. Okay. Just. Age something. Just you can write whatever. Okay. So here, for example, here display is equal to C plus D. What? Just whatever you can think. C plus D plus 1, whatever. Just it will return that is display. Assume that display is written. You can take any other variable here.
Where display will be stored? Function display storage will be there inside as data.
One
Inside
minute.
code inside data memory only the display function will be stored, or in the heap memory?
No. See, for example, first of all, this code is part of code segment. Okay.
Okay.
This code is part of code segment. Okay. And whenever elaboration is happened, that time, okay, this A, B occupied here. And whenever this function means, so whenever this function is called, here I'm calling this display, right? Z is equal to display.
Yes.
So Z is equal to display. So actually, because this is a static function already, this is also aligned to this one only, CD. It's already part of data segment only. Okay.
Okay.
So here Z is equal to display means always it will go to again the segment only, and it will go to CD. Okay, and it will do, for example, C plus D plus 1. For example, initially 0, 0, 0, 0, 0 plus 1. So display is now 1. Okay. So now Z is equal to 1. Okay. I think this example is not good. Just I will let one more example.
Okay.
Is it okay to continue on this one or need to skip? Sati?
We can continue here.
Because okay. Assume has 3. I will write neatly. Sometimes my pen is not working. Yeah.
Did you want to use return type
Which one?
for function return?
Function should return.
Okay. Just I function. Just I will return C here only. Okay. Return C only. Okay. Assume that is also integer only. Okay. So here assume I will take D only. D is equal to D plus 1 into D. Okay, so now here I'm calling C is equal to increment. And one more time, next time also I am calling multiple times. Okay. So now just I will explain. Okay. So because this is static, everything is data segment only. Just assume that one data segment only. So this is A, this is B, this is C variables. These are the model variables, not the function variables. And now function increment. So that function variable D. So this is D. Okay. This D. Okay. So now whenever you call C is equal to increment, what will happen? So D here int is equal to D, right? Int D means the initial value is equal to 0. So now all initial values is equal to 0 because they are uninitialized variables. So their initial value is equal to 0. Okay. So now C is equal to increment. So means it will call this function. Okay. Now int D, even though here again first time int D means D is declared. So this is first time D is 0 only. So D is equal to D plus 1, 0 plus 1, return D. So after this in the C, what is the value you will get here?
1.
1. 1. Okay. Okay. What about D?
1.
Hello.
1.
Okay. Here
1.
Here also D is 1.
D is equal to
D is 1 only.
C is 1.
Y 1. And next
Um,
time, I am telling second time. First time, okay, what you are telling C1 into D means every time those are same location only. Okay. Even though you came out of that one, still D is in this one only. Okay. Hello.
mm.
So means their lifetime is throughout simulation, not only during function return. Okay.
Okay.
And Swati understood?
But int we are again declaring. No, will it not?
No, we're declaring, but again it will occupy the same location only. In that location already D is equal to 2. Hello.
Okay.
So here because only memory is allocated only one time, that is starting only. So you are updating the same location only every time.
Okay.
Hello.
Yeah.
That is the static thing. So if it is static, right? So memory is allocated only once. That is in the data segment. So that's why data segment is generally preferred on all the uh, all the variables declared as the inside the module. Hello. You have any doubt? Just tell me. I will clear.
No.
No, right? So whatever you write inside the module, that is static only. So static means that function. So that functions. So the variables declared in the module also occupy the data segment only, and the function also occupy the data segment only. But what we cannot do is here you cannot access like this. You cannot write in .d. Hello. So we cannot access like this. For example, C is equal to increment of .d. So means we cannot access the D variable inside the increment. This is not possible. Okay. Because the D variable, their scope is part of that increment function only, not outside the increment function. Okay. So what I am trying to tell here is here D is its scope. Scope is only function only, inside function only. You cannot access this D outside of that function. Means in the same module only, you cannot write increment of increment function .d. It is not possible. So its scope is within function only, but its lifetime. Okay. This lifetime is throughout simulator. So means even though you after you, for example, after first function, you come out of that function. Still, the D is allocated in that memory only, so it will never be destroyed. So their lifetime is throughout simulation. Okay.
Okay.
Sorry, you have any doubt?
Understood.
Right? That D scope is function only. Lifetime is throughout simulation. Now we will come to variables declared in the module. Okay, A, B, C. Okay. Scope. Their scope is like okay. So this scope, for example, who can access this variable? So I will tell one more. Okay. Can we write, for example, this module name is equal to, for example, module TB or module DUT. You can assume module name is equal to DUT. Okay. End module. We have one more module TB. Here we have DUT T0, for example. Can we write like this? Or can we assign any variables for this one? For example, initial is equal to 10. Can we write like this?
We can write.
Hmm?
We can write.
So is this possible? For function, I told you, right? This is not possible. For module, it is possible.
It is possible.
Yeah, for module, it is possible. So means this is part of module. Whoever instantiate that module, they can also access that variable also. Okay. Scope is that module only, but accessed by anybody. Okay. Means here accessed by anybody means not means you need to access with module name only, without okay, instance name. Okay. Same. Lifetime is also same. Lifetime also throughout simulation they will be available. Okay. So that is the difference between these variables in the function and variables in the module. Okay. And even inside the function also you can use this ABC also. Okay. Hello. Inside this function increment, right? You can use ABC also here inside. Okay.
Okay.
You can use here, for example, one more D is equal to B plus C. You can write like that also. So means you can use these variables inside the function also. Okay. So you can use anywhere. Within the module also you can use anywhere, and outside the module also. Means outside also we can use anywhere these variables. But the variables declared inside the function we cannot access anywhere. Only that scope is limited to that function only. Outsiders cannot access. Okay.
Okay.
Okay. Okay. What happened? Any confusion?
No.
They introduced, means system Verilog is still backward compatible to Verilog, and again they introduced one more call automatic. Okay, for the function means for the same module. So you can write automatic here. Okay, automatic function. For example, here int d. Okay, d is equal to d plus 1. End function. Okay, same int a b c. Same code which is there in here. Same. I am not writing entire code. Same. Assume same this initial block. These 3 times is there in here also. Okay. So now now here automatic is there. Okay. This is not there in the Verilog. Okay, here it came. So model date in ABC automatic function. So whenever it is automatic means it won't allocate its memory in the data segment. Okay.
Okay.
Okay. Data segment is only for static variables, not for the others. Okay. So now if you go to the data segment, so this is the data segment. So only A will be allocated, B will be allocated, C will be allocated. Okay. So because function is auto, so what I told you for automatic we can use stack memory. Okay.
Okay.
So automatic is stack memory. So stack memory will it be allocated now only? So will it be allocated during elaboration or when? When it will be allocated?
During runtime.
During runtime means only during simulation only that will be allocated. Okay, means if we, for example, in our case, so here I am writing c is equal to increment c. I am calling c is equal to increment c. Okay, so now I am writing increment c. So whenever your code comes to this point, increment c. So then this function called. Okay, so then for this function it will allocate in the stack segment. So stack segment always grows from top to down, means first it will approach to the d here. Okay, this is the entire stack segment. Okay, so it will occupy d here. Okay, so first d here, so now d is equal to 0. Okay, after that d is equal to d plus 1, so again d value is incremented to 1. Okay, and whenever it is the end function means it come to the again this pointer only. Okay, so now c is equal to 1. So what about d? Hello?
D is
D
1.
will be 1 only.
D will be not 1.
T will be 0.
Why 0?
Initial int value.
No, it's not like that. See, whenever c is equal to increment means function called. So whenever function called, first automatically that stack segment will be created. So first value int d is equal to 0, enter it inside function. So initialize the d, later d is equal to d plus 1. Again end function means it will return to again main code, right? So whenever it comes to main code means the already that stack which is allocated, again that stack memories will be deleted automatically. That's why it is automatic.
Okay.
Okay. Means earlier, for example, this is int. So earlier this 4 bytes is used for that variable d, right? So now after this function is coming out of, means function is now not existed. So that the d value is assigned to the c and this stack will be deleted. So now you cannot see this same stack for the that function. Okay. So next time again, for example, if I call second time c is equal to increment. Okay. So now what will happen? Tell me after this. So here you can see c is equal to 1. Okay. Now tell me here what will happen here.
Again, the function will be called. Again, stack memory will be created. Again, d value will be 0, d to 1. Again, c will be assigned to 1, and d again will be removed.
So here same. Okay. Again means whenever function call means it will always allocate a new memory. Okay. R means new memory means it's already deleted. So why again it's new memory means again earlier that memory used for this purpose C variable. Now second time also it can come the same location, but previous values won't be there. Means maybe understood.
Understood.
Earlier, this D will be allocated. For example, this 1000 address will be allocated for that D. Okay. So now D is equal to 1 that time. So stack will be removed means this location is free. So means in that location nobody is there. Okay. Maybe second time C is equal to increment means again that time also it will occupy the same memory. Again D is equal to 0. Again D is equal to 1 only. Okay. So every time that memory will be created every time. Stack will be created, not memory. Every time that stack will be created. Okay.
Okay.
So that's why module. So now I will tell you. You can tell me scope and lifetime of this scope and lifetime. Tell me the scope and lifetime of this automatic means the variables inside the automatic function. Tell me this one based on your understanding. Swati, you can tell me.
Scope is still a function only,
Yeah.
and lifetime is still the function is being executed.
Yes, only that is okay. Lifetime means it is not throughout the simulation that variable is allocated. Only whenever it return to that function, right? So whenever it returns, lifetime is gone. That variable is gone. Okay. Whereas start a function, that lifetime is throughout simulation. Means throughout simulation that D will be existed there only. But there also we cannot access with the functionally we can access there also within scope. Okay. Manoj. Okay.
Yeah.
Okay. So now you understood the concept of automatic. This one. Okay. This one. I wanted to ask something. Okay. For example, automatic function only. Inside automatic function, can I use static variable?
No.
Why?
Yeah, we can use. Sorry, we can use. We can use static anywhere.
Okay. This static is remaining static. Okay. Still, I will continue this module only. Okay. Okay. This is one second function increment 2. Here I am writing static into D. So now tell me what will happen. Same logic here. I am D is equal to D plus 1. Okay. Just tell me what will happen here. Hello.
When the function is getting called, static int means the variable, the static variable will be declared inside data segment.
So
Then
when this memory will be this memory will be assigned for that one.
this memory will be assigned